Recently, from our past lessons, we have tackled about the fuels and combustion terms. Let me first have your presentation. Uh, go to your uh, Go to your fuels and combustion summary. You can click the link in your homepage that is linked to this module. So let us go with your summary for the fuels and combustion. We'll talk about the formula that is involved in determining different parameters in your fuels and combustion. Okay? Are you now looking at your module? This will be the last module and the last lesson that will be tackling about this final term. And I hope that you will learn all these formulas. So, to recap, we have tackled about the gravity units, the specific gravity at given temperature, the higher heating value of your fuel, the lower heating value, the air-fuel ratio, and lastly, the ideal gas ratio. And now will use them, we will use them to solve sample problems where I got from recent or past board exams. So I am preparing you not only to be a graduate, but I will prepare you to be board ready. Since at these times we can have face-to-face classes, so I'll do my best for you to learn all these topics. But for now, let us go with the combustion summary. And for the first part, we will talk about the API and Baum gravity units. API is the acronym for American Petroleum Institute. Now, you will use these values in determining the higher heating value of your fuel. Now, for your API, for the degree API, that is given by your formula 141.5 divided by the specific gravity at your standard temperature, which is 15.6 degrees Celsius minus 131.5, and then degree Baum, that is given by the formula 140 divided by the specific gravity at your standard temperature, again, which is 15.6 degrees Celsius minus 130. As you can see, in both formula, you can distinguish the difference between them. At the API, it is the first part or the numerator part is greater of about 1.5, and then the last part is greater by 1.5 also. And then I've summarized the formula. If you are always in different types of problem, when you encounter different types of problem in fuels and combustion, it is always asked, the SG is always asked at the standard temperature, which is 15.6 degrees Celsius. And I've summarized that, and you can use this. So it is given by the formula 141 for API divided by degree API plus 131.5. The same with the specific gravity at 15.6 degrees Celsius using the Baum gravity units. That is 140 divided by degree Baum, the value, plus 130. Now, we can recall that the specific gravity is not always given at standard pressure. In the field, it is also called, or the temperature here is also called the transport temperature or the handling temperature of your fuel. Now, for the specific gravity at that given or specific temperature, as the formula is given by this one, the SG at the standard temperature, which is 15.6, again, multiplied by the correction factor. Now, what is the correction factor? The correction factor is given by the formula 1 minus 0.0072 multiplied by the difference between the given temperature minus the standard temperature. And that is for SI units, which is 15.6. And then for English units, if you are given English units, the formula will be 1 minus 0.004 multiplied by the difference between the given temperature and then the standard temperature. Okay, class, we have visitors and then we have spectators like our dean, Miss Ma'am Yumul, our head, Sir Nicanor Serrano, and then Ma'am Napud, which is the VP for Finance. So let's greet them and let us welcome them to our discussion for today. Class, let us greet them. A good afternoon.
Good afternoon po, ma'am.
Afternoon,
Sir.
ma'am.
Good afternoon.
Afternoon.
Afternoon po.
Okay, so we are expecting to be visited by our president, Ma'am Dr. Elizabeth Lahos. Okay. Thank you, Ma'am Yumul. Hi, Sir Nick, and then hi, Ma'am Napud. So let us continue. Going back, for the higher heating value of your fuel, we've talked about the definition of this higher heating value. Now, I will show you how you can calculate the higher heating value for different types of fuel. I gave you three types of fuel. The solid, the liquid fuels, and then the gaseous form fuels. Now, we will use one of the most prominent formula for the heating values, which is Dulong's formula. Now, the Dulong's formula for coal analysis, or otherwise known as the ultimate analysis of coal or the mass basis analysis of coal, you are given the equation 33,820 multiplied by C plus 144,212 multiplied by the difference between H minus O divided by 8 plus 9,304 S. That is in terms of kilojoule per kilogram. But what is C? What is H, O, and S? C, H, O, and S are the chemical compositions of your coal or any fuel. C stands for the chemical formula for carbon. H is for hydrogen. O is for oxygen. S is for sulfur. Now, the values of C, H, O, and S, or the Chon-sum values, are commonly given in percentage. But in this formula, you will input them in terms of decimal form. And for oil products or liquid petroleum products, otherwise known as the ASME formula for petroleum, or ASME stands for American Society for Mechanical Engineers. It is given by the formula 41,130 plus 139.6 multiplied by the value of degree API. That is the one that I'm telling you about recently. So for degree API, and then the unit will be in kilojoule per kilogram. Now, for if S is given, you'll use the Bureau of Standards formula for the higher heating value of your fuel. That is also given by the formula 51,716 deducted by 8,793.8 multiplied to the square value of your specific gravity. And it is also in kilojoule per kilogram. But if you are given by hydrocarbon, if you are given with the hydrocarbon formula, hydrocarbons, for example, let's go back. You are given butane, pentane, hexane, heptane, nonane, decane. You'll use the formula for the higher heating value, 13,500 multiplied by C plus 60,890H. And the unit will be BTU per pound, or British thermal unit per pound. where C is given by the formula 12N divided by 12N plus M, and then H equal to M. N and M are subscripts of our carbon and then hydrogen. And they are also in decimal form. Now, for lower heating values, this is not quite given in your board exam. In my past board exam, it is not asked. But I will still tell you this because it might come essential to you in your board exam year. So the lower heating value is equal to the higher heating value minus 9 H2. What is H2? That is hydrogen. It is always diatomic multiplied by 2,442. And it is also in kilojoule per kilogram unit. And H2 or the hydrogen is equal to 26 minus 15 multiplied by your specific gravity or the specific gravity of your fuel. And it is in percentage. Now, for the air-fuel ratio, I also summarized the formula for that for you not to do the chemical analysis anymore. For the chemical analysis, will take quite some time for you to solve. So, the air-fuel ratio for theoretical values, it is given by the formula for coal. It is given by the formula 11.5 multiplied by C plus 34.5 multiplied by the difference between the H minus O divided by 8 plus 4.3 S. Now again, C, H, O, and S are in decimal form. For given hydrocarbon with chemical formula of Cn and Hm, where N and M are the subscripts or the number of atoms of carbon and hydrogen, the air-fuel ratio, I summarized that again. For theoretical value, it is given by the formula 32 plus the product of 3.76 multiplied by 28. And I discussed that to you, how they derive that. Divide by 12N plus M, where N and M are the subscripts or the number of atoms of your chemical formula for each chemical symbol. And then X is given by the formula N plus M over 4. Now, for the shortcut of your heating values, it is given, or you can use these formulas for different given units. If you are given kilojoule per kilogram in your higher heating value, just divide that with 3,117, and the unit will be kilogram of air per kilogram of fuel. And if you are given English units in BTU per pound, you simply divide that with 1,340. And that is also in kilogram air over kilogram fuel. And then if you are also given in kilocalories per kilogram, you simply divide that with 745. And also that is in kilogram air per kilogram fuel. And for the ideal gas to fuel ratio, that is given by the formula, the entire air-fuel theoretical ratio plus 1 will be equal to the ratio between your flue gas and the fuel used. Now, for the actual values of your air-fuel ratio, you just multiply that with the sum of your 100% of your air-fuel theoretical ratio, and then added by the excess air, if excess air is given. Okay? And then we'll proceed with, since we are done with this, we'll proceed with the solving of the problems. I prepared 10 problems which are actual board exam questions. Okay? And then I will solve that in impromptu. So go to your modules again, that is uploaded as PowerPoint format, so we can answer this. Okay, let me just take this away, and then let's go with your whiteboard. Okay, Can you see my presentation, class? Just pin the screen where I am presenting. So unpin the presentation. And then pin the whiteboard. So we can now proceed with the solution. So let me just check the problems. Okay. So that is the last part. It is placed in the last part of your module number 6. So for fuels and combustion samples. Okay, let's proceed. So for when I'm solving the problems, you may get your calculators and then solve with me simultaneously. So if ever you get the answer, you can chat it in the chat box, and then we can consolidate our answers if we are correct. We arrived with the correct answer. So let's proceed. Get your papers. You can jot down notes and then solve this. Try this on your own, and I will solve this. Okay? For number 1, the problem is a diesel power plant consumes 650 liters of fuel at 26 degrees Celsius in one day with 28 degrees API. Find the fuel rate in kilogram per hour. So you are asked here to get the mass flow rate of your fuel. You are given with the volume, which is given and then transported to your bunker or your tank at a given specific temperature. It is not given in 15.6, which is your standard temperature with fuel. And it is utilized in one day with a given API unit of 28. So how will we solve that? Now, if we are given with the volume, we can relate the volume with your density. And going back with your thermodynamics 1, density is given by the formula, the mass of your substance divided by the total volume of your substance. But in this case, it is given that your volume is given at a given temperature, sorry. And as I have said in the summary, we can get the standard specific gravity at your standard temperature, okay, given the API unit. So go to your board or your notes. I will solve this. Okay. So solving, we are given 650 liters at 26 degrees Celsius and then degree API. So for solution, the SG at 15.6 degrees Celsius is equal to 141.5 divided by the given degree API unit. The given degree API unit, the given degree API unit is 28. So you add that with 131.5. So let us leave this aside. So we will use our calculator. And then once you get the SG, you will get the specific gravity of your fuel at 26 degrees Celsius. And the formula for that, you simply multiply the value of your SG at 15.6 degrees Celsius with the correction factor. Now, the correction factor is given by the formula 1, since it is in SI units, 1 minus 0.00072 multiplied by the given temperature minus 15.6 degrees Celsius. Now, I will calculate it. Okay. Now, can you see the calculator? Class, can you see the calculator?
Yes, sir.
Yes, sir.
Okay, thank you.
Use the calculator.
Thank you for replying. Okay. Okay. So we'll solve that. Okay. Now, Every time you will solve a problem, you will always have to clear the calculator for it to function well. Sometimes it may be erroneous if you will not clear the memory. Okay, just a reminder. Since you will take your board exam 2 sems away from now, and then we will solve the SG at 15.6 degrees Celsius. Okay, so 141.5 divided by 28 plus 131.5. Okay, so the answer will be 0.887174. So we can store this value in the letter A. So this is 0.88715. Okay. Now, for the correction factor and then the SG at 26 degrees Celsius, we can input that 1 minus 0.00072 multiplied by 28 minus 15.6, which is the standard temperature. 15.6, okay. And then we multiply that with your stored value at A, which is the SG at 15.6 degrees Celsius. Now you will arrive with the standard specific gravity at 26 degrees Celsius, which is 0.8792923. So, anyone who got the correct answer? Okay. Okay. So, this is the answer. Now,
Opo, sir.
okay. Is this correct, Mr. Balin? Did you get the correct answer?
Correct po.
Yes. 8716. 87923. Okay, that is correct. Now we will solve for the mass flow of your fuel in a day. Now let's go back with your whiteboard. Okay. We solve the value for your SG and then the SG at your given temperature. Now we will set that aside. Okay. Now for the mass of your fuel, we will recall that density is mass divided by volume. Okay? Now we are asked to find the mass of your fuel. This one. The volume is given, the density is solved. The density we'll use there is the density at a given temperature. Okay? Now, we can simplify this. Therefore, the mass flow of your fuel is equal to the density multiplied by the given volume. Okay? Now, for the mass of your fuel, it is quite a bit of conversion of units. So, let us first list down the volume in liter per day. Okay. Now, the density of your fuel, as you can see, the density is given by the density of water multiplied by the SG of your fuel or the specific gravity of your fuel at the given temperature and then multiplied by the volume flow rate. Okay. Now, we can see that the density of water is 1,000 kilogram per cubic meter. But to simplify that, I will give you a shortcut. The shortcut will be 1 kilogram per liter. That is the standard density of water. In every kilogram of water, in every 1 liter of water, there is 1 kilogram in mass, in terms of mass. So, we'll use that. So, 1 kilogram per liter ang the density of your water. Now, multiply that with the standard specific gravity of your fuel, which is, we solve 0.87923. And then, what is asked? What is asked? What unit? That is in kilogram per hour. So, we will convert the day in hours. So, 1 day is 24 hours. Okay. So, for the answer, let's go back with our calculator. Hold your calculators. 23.8125. Thank you, Mr. Thank you, Mr. Uh-huh. Divinagracia. Oh, Mr. Divinagracia got it correctly. So, let's check. Let us check his answer if it is correct. Okay. Okay. Pin the calculator in your screens. So, shift. Okay. We store this value in B. So we won't have to input that again later. So 650, that is 6, okay, 650 multiplied by 1 times 1 times point, no, the stored value, alpha B, divide by 24 since 1 day is 24 hours. So this will be in kilogram per hour. So 23.8123 kilogram per hour. So Mr. Divinagracia is correct. Very good, Mr. Divinagracia. Very good. Okay. So go back with your whiteboard. So we are done with this. So the answer will be 23.8123 kilogram per hour. Okay? Uh, anyone who didn't get the correct answer? I think all of you got it, especially Mr. Divinagracia, who is very fast in calculating. Okay. I think he reviewed the problems a while ago. Okay, let's go with number 2. For number 2, a diesel engine consumed 945 liters of fuel per day at 30 degrees Celsius. Again, it is same with problem number 1. But here, you are given the cost of the fuel per volume. So what is asked here? Determine the cost of fuel to operate the engine per day. So if the fuel is purchased at 15.5 degrees Celsius, so you can say it is almost 15.6 degrees Celsius, and at 30 degree API at 5 peso per liter, that determine the cost of fuel to operate the engine per day. So we will have to determine that. So first, what we have to do is get the specific gravity at 15.6 degrees Celsius, and then again get the specific gravity at the given temperature. That is the process, and we will get the cost for the fuel. But we will have to determine the volume of your fuel at 15.6 degrees Celsius. I'll tell you the ratio later, okay? So let us first solve this. Solve for the SG. Specific gravity at 15.6 degrees Celsius. Okay. So it is given by, if you are given degree API units, again, 141.5. So the API is 30, I think. Okay, that is 30. Okay, 30 API. That is 30 plus 131.5. Okay, let's set this aside. So proceed with SG at 30 degrees Celsius. So we will multiply this with the SG at 15.6 and then the correction factor. Where your correction factor is equal to 1 minus 0.00072. Don't forget that. The given temperature minus 15.6 degrees Celsius. Okay. Now, the SG will be, let us solve. Again, solve with your calculators. Okay. Okay. So, it is pinned. Let's clear, always clear the memory of your calculator. Okay. So, first we will solve for the specific gravity at 15.6 degrees Celsius. Okay. 141.5 divided by 30 plus 131.5. So, the answer will be 0.87 0.87616. 0.87616. So we will store this again, the value at alphabet A, and then we will proceed with solving the value of your SG at 30 degrees Celsius. So we will first calculate the correction factor. So 0.00072 multiplied by 15 points, no, that is 30 minus 15.6 multiplied by, recall your value for A. Okay, the value will be, okay, 0. Mr. Balin, thank you. That is correct. 0.8671. And then Mr. Divinagracia, very quick in solving. I think Mr. Balin got the highest grade in preliminaries. So thank you, Mr. Balin. Mr. Palomares too, thank you. They are participating with calculations, so I can check the answers. So you got 86.71 and then 87.616. So we'll have to proceed with solving the value of the volume for 15.6 degrees Celsius. So remember this one and this one. Okay, we'll use that later. Okay. How will we get the volume for your standard temperature? Let's see. Since the volume is given by the mass divided by density, and then the density of your fuel is equal to the density of water multiplied by the SG or the specific gravity at given temperature. We call this one. And we can create a ratio and proportion between them. Okay? So the volume for 30 degrees Celsius divided by the volume for 15.6 degrees Celsius. Okay? We can see this one. So the mass of your fuel is still the same between the different volumes. But what made them different is their specific gravity. So this is all over. So mass divided by the density of water, SG of your fuel at 30 degrees Celsius. And then mass of your fuel divided by density of your water multiplied by SG or the specific gravity at 15.6 degrees Celsius. This way, we can cancel the same units and the same values, okay? The mass is canceled and then the density is canceled. And since it is in your denominator, you can cross-multiply, so we can make this our numerator and then this will be your denominator. Okay. Now, this is SG at 15.6. And then SG at 30 degrees Celsius. Now we can solve for the value of volume at 15.6 degrees Celsius. Okay. So the volume, let's simplify this one. Okay. So the volume at 15.6 degrees Celsius will be given by the formula okay. Volume at 30 degrees Celsius multiplied by SG at 30 degrees Celsius. Divide by SG at 15.6 degrees Celsius. Now you have the values for your HSG, and then you have also the value for your volume. And recall, your volume is 945 liters per day. 945 liters per day. You multiply this with SG at 30. The SG at 30 is specific gravity at 30 is 0.8671. 0.8671 divided by 0.87616. 0.87616. Okay. We can calculate the value for your volume at 15.6 degrees Celsius. And now we can finally compute for the value of your fuel cost per day. So the cost per time will be equal to the volume rate per day multiplied by the cost per volume. Okay. So the cost per volume is 5 pesos. 5 pesos per liter. Multiplied by the volume at 15.6 degrees Celsius. So we'll solve that. Again, go back with your calculators. Okay. Okay. Again, we will clear the calculator. Now, we will solve for the volume at 15.6 degrees Celsius. The volume will be 945 multiplied by 0.8671 divided by 0.87616. Okay. So the volume at 15.6 degrees Celsius is 935.22812. So we will store that in A, and then we will multiply it with the cost of your fuel. So Mr. Jo Marie Leona and then Mr. Balin is correct. Okay? And then Mr. D. Vinagracia, thank you for calculating very quick. So 935.2066, then 935.2066 liter per day. So the cost per day will be 4,676. 4,676 pesos. 0.14 centavos per day. Okay. You're very quick in solving because we have discussed it. Okay. So the answer is 4,676.14 per day. Okay. That is for number 2. Now we will proceed with number 3. Let me erase this first. Okay. Okay, so for number 3, the problem is a certain coal has the following ultimate analysis. Now, when you read ultimate analysis, what comes in your mind? What comes up in your mind? Class, I told you, when coal analysis is involved and you are asked to get the heating value, you will always use the Dulong's formula. And the Dulong's formula, we will recall, yes, Mr. Divina Gracia, very active, that is correct. The Dulong's formula is given With the formula, 33,820 multiplied by the percentage of your carbon by mass, added with 144,202 multiplied by the percentage of your hydrogen, diminished by the percentage of the oxygen divided by 8, plus 9,304 multiplied by the sulfur. And the answer will be in kilojoule per kilogram, the unit. So, we don't have to list this down, but in sake of our calculation, we will list this down, okay? So, for your HHB or the higher heating value, that is 33,820 multiplied by C plus 144,212 multiplied by the hydrogen minus O, 8, excuse me, 9,304 of your sulfur. Now C is 69%. The hydrogen is 2.5% in the problem. And then oxygen is 3.5% by mass. And then sulfur content is 7%. So how will you solve this using your calculator? And then I'll show you by barely using your calculator without consuming too much time. Okay, let us solve this. Okay, hold on to your calculators. I will show you. Hold on with your calculators. Okay. This is the way you can solve this. Okay? So, you will input 33,820. And then you will multiply it. Just make the parenthesis. Okay? So, you will let this as alpha A plus 144,212. And let your H be the alphabet B minus let the oxygen as alpha C. Divide this with 8 plus 9,304, and then alpha D. You have 6 letters here. Always, you will not use X and Y, okay? The 6 letters could be the variables where you can input the values. So, what will you do next? You will press calculate. The calculate function of your calculator. So, you will input the value of A, which is, we denote A as the value of your carbon, which is in percentage, that is 69%. So, this will be, you input 0.69 in decimal form, as always. Then B is 0.025 since 2.5%. Okay, C, which is your oxygen, that is 3.5%, 0.035. And then for letter D, for your sulfur content, 7%. So 0.07. So the answer will be 26,961.4525 kilojoule per kilogram. Anyone? Okay, Mr. Divinagracia again, very quick in solving. Mr. Balin, is the answer correct? Mr. Tagupa, thank you. Okay, so we arrived with 26,961. So that is the shortcut for calculator, okay? You can solve this by using just your pen and paper. But I want to show you the easiest way and the quickest way, okay? Then let's move on, go to number 4. Okay, for number 4. Okay, for number 4, Mr. Balatukan, thank you. Correct also. Thank you for correcting the answer. For number 4, a diesel power plant uses fuel that has a density of 892.74 kilogram per cubic meter at 15.6 degrees Celsius. Find the heating value of the fuel at 30 degrees Celsius in kilojoule per kilogram. Now, we will analyze this problem, okay? You are given a density, a certain density at your standard temperature, which is 15.6 degrees Celsius. But the one we need is the heating value of the fuel in 30 degrees Celsius. The problem here, we don't have the density for 30 degrees Celsius temperature of your fuel. Now, what is the best uh, calculation formula to be used? We can recall that when we are given this one, for you to determine the heating value of the fuel, a liquid fuel, you will use the ASME petroleum formula. Okay? We will recall the ASME petroleum formula for heating value is equal to 41,130 plus 139.6 multiplied by the degree API of gravity units. But we still don't have the SG at 15.6 degrees Celsius. Okay? Okay. The one we need is the SG at 15.6 degrees Celsius. Already we have the density. Now, in your recent discussions, I gave you the formula for SG. So for the formula for SG, the specific gravity of any substance that is given by the formula, the density of your substance divided by the relative substance. But the relative substance here is always water. Okay? Now, we are given the density of your fuel at 15.6. And then, the universal density for your water is 1,000 kilogram per cubic meter or 1 kilogram per liter. And since we need a non-unit item or a unitless item, which is SG, we will just simply solve this by dividing the density of your substance by the density of water. So 892.74 kilogram per cubic meter divided by 1,000 kilogram per cubic meter. Okay, we set this aside and then we will find the degree API. So the degree API will be 141.5 divided by the SG at 15.6 degrees Celsius minus 131.5. Okay. And then, we set this aside again. This is letter A. Okay, this is letter A. This is letter B. We store this at the values of your calculator. And then the HHV or the higher heating value will be HHV will be equal to 41,130 plus 139.6 degree API. What will be the value of degree API? Okay. So let us use again our calculator. Okay, we will clear the values. Shift, clear. Okay. So first we will solve for the value of your SG at 15.6 degrees Celsius. So that is 892.74 divided by 1,000. Okay. And then we will store this value to letter A. That is 0.0 0.89274. 0.89274. Okay? And then it is already stored. We will get the value for your API, which is 141.5 divided by the stored value at A, diminished by 131.5. Okay. So the degree API unit is 27 degrees. Okay. And then we will store this value again with letter B. Then we will use it to solve for your higher heating value. So for the higher heating value, 41,130 plus 139.6 alpha D. So Carlo Palad got the correct answer. Mr. Balin, Mr. Balatukan, Mr. Bilyedo, correct? Okay, thank you. You got it correctly. The unit will be kilojoule per kilogram, correct? Mr. Joven Rivera, Miss Kilasio got the correct answer too. So, very good class, very good. You are very well attentive. Okay? So, okay, the answer is 44,899.31. Okay. So, the questions are very easy for you since we already tackled how you will cope up with these types of problems. Okay? You are now ready to take your final exam on Friday. Okay, so let's move on and then what problem are we in now? So I think we are in problem number 5. Okay? So for problem number 5, a diesel power plant uses fuel with heating value of 45,038.8 kilojoule per kilogram. What is the density of fuel at 30 degrees in KPL? What is KPL? That is kilograms per liter. Okay. So this is quite a bit long problem. For you have to first get the API unit of your fuel, and then you will use that API unit to get the SG at 15.6 degrees Celsius. And then you will use the SG at 15.6 degrees Celsius to get the value for your specific gravity at 30 degrees Celsius. And then you will get the fluid density at 30 degrees Celsius using the SG and then the density of water. So we will solve this part by part, okay? So first part, the HHV of your fuel is given by 41,130 plus 139.6 degree API. And since degree API is missing, we will have to simplify that out. Okay. For the degree API, take note of this, I already simplified this for you. This one. The degree API will be the higher heating value minus 41,130 divided by 139.6. But the given value is 45,000 for your HHV. 45,000 0.038. 45,000 038.8. Okay. This is A. And then once you got the degree API, you will get the SG. And then the SG is given by the formula. You will recall, go back to your handouts or your module that is already listed. Okay. 10.6 degrees Celsius. 141.5 degree API unit plus 131.5. Okay. You will arrive with, set this as letter B. Okay. And then you will solve for the SG. SG at 30 degrees Celsius. We will solve this part by part. So the correction factor, which is 1 minus 0.0072 multiplied by the temperature given, which is 30 degrees Celsius minus 15.6 multiplied by, okay, too quick, SG at 15.6 degrees Celsius. SG at 15.6. Okay. Okay. Mr. Tagupa, let us see. So, let us get back with our calculator. Percent. Okay. See. Calculator. Okay. So, that's clear. Okay, let us spin this. Okay. Let us solve. First, we will solve for API. So, API is 45,038.8 minus 41130. Divide by 139.6. Okay. So, the answer will be 28, correct? Mr. Tagupa is correct. Mr. Palad is correct. I can see them solving very quick. Yes, Mr. Tagupa, thank you. So, we will store this value at A. And then we'll solve for the SG at 15.6. 141.5 divide by, recall natin yung value of A. And then 131.5. Okay. So, we will store this again. This is 0.88715. We store this with B, and then we will solve for the SG at 130 degrees Celsius. So, let us first solve for the correction factor. 1 minus 0.003072 multiplied by 30 minus 15.6. Right. And then we will multiply this with the value of B. So, the density is 87795. 87795. 0.87795. Okay. So, now we have the values for your SG. And then we can now solve for the value of your density. Density of your substance at 30 degrees Celsius is equal to the SG at 30 degrees Celsius multiplied by the density of water. And since we are asked to determine the value of your density in kilograms per liter, we will just simply use the conversion factor for the density of water, which is 1 kilogram per liter. Okay. So we will just simply multiply this to get the value of your fuel at 30 degrees Celsius. Density at 30. So multiply this by 1 kilogram per liter. The answer will be 0.87792. Correct. Okay. Multiply by 1. Okay. Okay. 87795, correct? Oh, all of you are correct. So very good. You are very much coping up with our discussion. Okay. So we solved 5 problems. Okay. So the answer is 0.87795 kilogram per liter or kpl. The answer is this one. Hey, very good. You are coping up. You are catching up very quick. Okay. Okay. Now we will go with problem number 6. I think you are very much ready for our final exam this coming Friday. So I hope someone from you will get the perfect score. Okay? I'm looking forward with that. It pays off seeing you perfecting our exams. Okay? Now for number 6. Problem number 6. A certain coal has the following ultimate analysis. Again, an ultimate analysis of coal. Okay? Let us read first. So for carbon, you are given 70% by mass, For hydrogen, 3% by mass. Oxygen, 4% by mass. Nitrogen, that is 5% by mass. Sulfur, 6% by mass. Ash, which is 5% by mass. M, or moisture, is 7% by mass. Now, determine the theoretical and actual air-fuel ratio if the excess air is a quarter of a total. What is a quarter of a total? It is
I
25%
have
of the total.
excuse. Hello. Jimbo excuse.
Hello, ma'am.
Okay po. Sorry, ma'am. I would like to acknowledge our president, Ma'am Elizabeth Quirino Lacus.
Hi, I
Ma'am.
Hi, ma'am.
Hello po, ma'am.
Hi,
Good
ma'am.
afternoon, ma'am.
Good afternoon po, ma'am.
good afternoon.
Last is greet the president and
Good afternoon, ma'am.
member with our discussion today. Ma'am, we
Good
are
afternoon.
currently discussing the final part of our term this day, and we would like to welcome you again and then thank you for attending.
Oh, you're most welcome. It is my pleasure. Actually, this is the third Canvas class that I have attended. I attended two in Quezon City the other night, and after this, I'll be attending another Manila class. And so far, I'm very happy with what I have observed in Quezon City and now with your class. No, you're a very how old are you? Is that Ian or Ayan?
Ma'am?
Is that Ian or Ayan? Your name?
Ian, ma'am.
Ian.
Ian
You're
will do, ma'am.
a very good teacher. How old are you?
27, ma'am. I currently turned 27 last day, June 16.
Oh, okay.
Recently.
Happy birthday.
Yes, ma'am. Thank you. Thank you very much.
Yes, and I can see you have the passion to explain to your students
Yes,
and
ma'am.
ability to explain. And I'm happy that you're using English
Yes, ma'am.
throughout. Okay, now I'd like to know your who was the star student that you were since a while ago because he's always fast with his communication.
Yes, ma'am. I'm very much amazed with my students. They are very quick in calculating my example problems. I have not
Yeah.
given these problems too soon, but they can cope up very fast. So I
Yeah.
think can do it in their uh, different classes. And I'm very much happy with the results.
Yes, I am too. So who was the who you were calling on three of them a while ago? May I
Yes,
talk?
ma'am.
And
The best,
to one of them, they should turn on their video.
yes, ma'am. Mr. Balin, Mr. Divina Gracia, Mr. Tagufa, please acknowledge our president. She is acknowledging your performance in our class.
Okay, so let's talk to Mr. Divina Gracia first. Can you turn on your
Mr. Dave,
camera?
please turn on your camera as per request of our president. Mr. Dave, don't be shy. Don't be shy. Mr. Divina Gracia.
Hi, ma'am.
I
Good
think
afternoon.
Hi. How do you find your class so far?
Ma'am?
How do you find your class so far? With John, how do you find your class with Ian so far?
It's interesting, ma'am, because he's doing his best to teach us whatever techniques that he uses in his past board exam. So it is very helpful for us.
Yes, that's very nice. What year level are you in?
Fourth year, ma'am, I guess.
Well, I guess. Okay. So, congratulations that you have come to this final. I mean, that's a big accomplishment. And this is our first ever purely online, right? So, I'm happy that you're
Yes,
there. So, who do I talk to? Oh, by the way, the first, will you first,
I'm sorry, ma'am.
will you enroll in the first semester?
We're still thinking about it, ma'am, because of financial reasons.
Yes. Actually, what you have to do is to settle your summer, okay? And then you still have if you still have an accountable in the second semester, you're also supposed to settle that. But if you do, you can enroll with only a small down payment. Alice, how much is a down payment? Alice, unmute your mic. Alice, she's our VP Finance. Alice, are you there? Unmute your mic. So, to be able to talk to who do I talk to next? Yeah. Yeah. Who next? Talk to Ian.
Okay,
Who
ma'am.
should I talk to next? Yeah. Thank you, John, David.
Okay, ma'am. The next one
Thank you,
I'm
ma'am.
okay.
Welcome.
Ma'am, the next one that is participating very well is Mr. Balin. He is the currently highest grader in our class.
Oh, okay. May I just continue what I was telling John David? John David, if you have paid your summer and your second sem, and there's a little situation about finances, then you can just have a minimum down payment of 1,500 in the first semester.
Oh.
Did you hear me, John David? Yeah, you're on mute, but anyway, I'm sure you heard me. Okay, so the one that I was trying to look for, which I found, which because Alice has not been able to answer, is the down payment is 1,500 instead of 3,500. If you paid both your summer and your second sem. Okay, so who's next, Ian? What were you saying? The one who's always answering perfectly. Who is it?
Yes, ma'am. He is the best grader in our subject. He is Mr. Ferdy Balin, one of my best students in combustion engineering. Mr.
Okay,
Balin?
can we?
Yes, ma'am. Yeah.
Hi.
Hello po.
Hi.
Good afternoon
You.
po.
On. How are you doing in the
Uh,
pandemic?
Study, ma'am. Stay at home, ma'am, and safe. Stay home, ma'am.
Very good. And what kind of device do you use to be
Uh,
able to do your this?
Cell phone, ma'am. Only. Cell phone only. Yes,
Yeah,
ma'am.
on a cell phone. Right now, I'm just using a cell phone
Yes
to
po.
yes, because
Yes,
I don't use a laptop or a tablet.
yes, ma'am.
The cell
I
phone
don't
work,
have one.
the cell phone works for you.
Yes, not as good, ma'am, but uh, it.
It will do.
Yes,
What do you like best about your class with Ian?
ma'am.
What do you like class with Ian?
Ma'am. He's a good, ma'am. Professor. Not only teach us techniques, but he's a good mm, a person, ma'am.
Ah,
I know him, ma'am, personally, ma'am.
you
In
yeah.
department, ME department.
Ah. So what you mean to say is he is a good teacher because he does not only teach well, his personhood or ang kanyang pagkakao maganda. Ibig mo sabihin, is that what you,
Yes po, yun po.
that's good. That's very nice to hear about our teacher. And do you think you will enroll first semester?
Yes, ma'am. I will, ma'am.
Okay, that's good to hear. And see you during
And
the first, and you will perfect your final exams, right?
yes, I need to, ma'am.
Okay. But even if you don't, I think the fact that you really are trying to work very hard, that's already more than enough. Okay?
Yes.
We cannot always be perfect or we cannot win all the time. But if we have done our best, we can look ourselves in the mirror and say that we have given it our best shot. That's very good. And congratulations, you've come this far in our very first purely online program. Thank you for
Thank
it.
you.
Nick, I know
Thank,
you're there. Nick,
thank you
you're
po.
here, right? And
Yes,
Alice.
ma'am, I'm here, ma'am. I'm very happy with my faculty member, and he's our also our alumnus. He's
Video.
our alumnus. Yeah, Engineer Ian Jimbo is our alumnus.
Okay, very glad about it. So maybe he was once your student because you've been here 20 years.
Hello,
Was
ma'am.
once your student? Was Ian once your student?
Yes, ma'am.
Was Ian your student once upon a time?
Yes, ma'am. He was my student since third year, and he is one of our quizzers during his time, and he won many quiz contests.
I've not seen your face.
Yes, ma'am.
Can you turn on?
Yes, ma'am. Hello, ma'am. Sorry, ma'am. Sorry.
Uh, to- Okay. Uh, who's the next one that I should talk to? Ian, who will I talk to next?
Ma'am? Hello, ma'am.
Who, who will
Yeah,
I
I
talk to?
think
Last
I
one.
think Miss yeah, I think Miss Iara Isabel, she is the currently the PSME president, and she has proposed a, uh, a program to survey our students whether they will enroll or not. I think Miss Iara is here. Please share the program of PSME. Iara, are you here? Iara?
Yes, sir. Good afternoon po.
Hi.
Good afternoon.
Hi. Yes. Yara.
Yes po. Okay. So, with the PSME, along with the help of Sir Nick, we have made a Google survey for the
Yes.
mechanical engineering department. So
Yes.
the objective of this survey is to um get to know the current situations of our fellow mechanical engineering students.
Okay.
So the survey has questions regarding on whether they'll be able to enroll for the upcoming
Okay.
first semester. And so far, we've already have 94 responses. Majority of them coming from the fifth year students. And
Okay.
yes, and so far, with the 94 responses, we've already garnered 87.2% of them are willing to enroll for the first semester. While for the remaining,
72%. Okay.
yes, yes, ma'am. And and for the remaining 12.8%, majority of the reasons why they wouldn't be able to enroll is because of their financial problems and lack of proper internet connection.
Oh, okay. Yes, the internet is really a problem and also the lack of devices, no? I'm just so glad that you who are here now in this class have at least cell phones or some kinds of devices that enable you to. Can you hear me clearly?
Yes, ma'am.
Yeah, I had to
Yeah,
step
yes,
out
ma'am.
because Alice told me my signal wasn't too good. Oh, but anyway, so how about you, Yara? Are you going to study next this coming first sem? Are you going to enroll?
Yes, ma'am. I'm planning to enroll for the first semester.
Okay, that's very nice. And congratulations that you're the DSME president, and thank you for your survey. And also congratulations that you have come this far because it's the finals week, right?
Yes, ma'am. Thank
Yeah.
you.
Thank you. Alice, are you there? Can I recognize you, please, Alice? Are you still here? Can you unmute your phone, your mic? Okay, you cannot seem to hear me.
Yes,
What
ma'am. I'm
about?
still here, ma'am.
Okay, why
I'm
don't you
still here,
unmute
ma'am.
your phone and show us your face? We cannot. Okay, we will not allow her to show her face because she doesn't want to show her face. Would you like to greet them? I just answered for you that the down payment can only be 1.5 if they have paid their second sem and their summer. Is that correct, Alice?
Yes, ma'am. Yes.
Yes. Alice is with finance, but you know why I asked her to join in this class? Because when we plan for online classes, for modular and stuff like that, it's not just the academics group, but the whole management group, okay? So, Yani, are you there? Din Yumol?
Yes, ma'am. Sorry,
Hi.
ma'am. I am also in a meeting with Sir Jello po. Sorry po talaga, ma'am.
No, it's
At the same
okay.
time po.
Yeah, multitasking.
Yes, ma'am.
What about Jemuel? Is our VP for Quality Management. Jemuel, can your
Yes.
face be seen? Can we
Oh.
show? Can you show your face, or we cannot?
I'm here.
You're there.
I don't
Okay.
know if you can see me.
We can see. We can see you. So thank you, Jemuel, for
Okay.
joining this class. I
Yes,
think you made the right choice in joining this class. And I'm about to say goodbye to the group, and we're joining the next class. Okay, Jamal, if you are already, if I know you're busy preparing for tomorrow's meeting,
Yes,
so
Thank you very much.
there might be Batangueños here whom you might want to invite to Adustria, the TIP-FEU partnership. Okay, go
Okay.
ahead. It's your
Yeah,
chance.
good afternoon. I'm Engineer Castillo. As you probably know, I'm the Vice President for Quality Assurance, but currently I'm spearheading a new project, a partnership between FEU and TIP here in Lima. Of course, Lima stands for Lipa and Malbar because the school is situated really in between Lima and Lipa, and Lipa and Malbar. It's called Industria Senior High School, but this is just a senior high school. So if ever you have some relatives who are residents of the vicinity, either in Lipa or in Malbar or Tanawan or Santo Tomas, we have a school here, a very nice school. It's called Industria Senior High School. It's situated at the outlets at Lipa, which is inside the Lima Technology Center. We're opening in August, just like your opening there in Manila, August 24. And also we're going online. So I'm very glad to see a real sample of an online class. So really, this is a learning experience for me. Thank you very much.
Thank you, Jemuel. So, Ian, you're the first teacher to be observed by the president, two vice presidents of TIP, the dean, and the department chair all together. I think that's quite an honor, okay? So I'm happy that your students are happy, and
Thank you very much, ma'am.
yeah, we will have to say goodbye in a while. And Nick, have you been able to explain to them about our modular delivery?
Yeah, yes, ma'am.
Classes?
Yeah, yes. So we have the platform for the
Yes.
discussion about the modular classes, ma'am. Yes, ma'am.
Very good. And to explain it simply as possible, it will still be semestral, right? We will have one
Yes.
semester and then a second semester. But inside the one semester, as you have modular group 1, modular group 2, modular group 3, it is like you have 3 summers inside one semester.
Yes.
And your load is like the same. It's just like 3 courses times 3 units, that's 9. And then you will be having the same number of days as in summer, 6 weeks. And so you're going to be not too much in front of the devices because you'll have a lot of time for yourself. Okay? So I welcome you to the next first semester, the upcoming one, and good luck on your exams. Thank you, everyone. Bye-bye.
Thank you, ma'am.
Congratulations,
Thank you,
Ian.
ma'am. Thank you, ma'am. Take care, ma'am.
Bye po, ma'am. Thank you po.
Bye po, ma'am.
Thank you, ma'am.
Bye, ma'am.
Thank you, ma'am. Bye po.
Okay, thank you guys. Thank you.
Thank,
Team
Thank
thank you,
Business.
ma'am.
Thank you po. Thank you po.
Thank you po, ma'am.
Thank you po,
Thank you,
ma'am.
sir.
Teacher.
Thank you, sir.
Thank you po, sir. Thank you po.
Thank you po, sir.
Thank you, sir Nick. Thank you, ma'am.
Thank you po, sir.
Hello. Can anyone see me? Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Congrats, sir.
Hello, class. Can anyone see me?
Yes, sir. Yes, sir.
Yes, sir. Kita ko, sir.
Can you see my microphone?
Yes, sir. Kita.
Okay. So we will proceed with our last 5 problems. So we still have 5 problems, and these are very short problems. We can finish this in a matter of time. For about 15 minutes, we can finish this. So I want to thank you first, the ones who are enthusiastically participating in the class. And all of you, I want to thank you. Especially Divinig Gracia, Mr. Balin, Mr. Tagupa. Okay, so let us continue. Okay, so let us continue class for number 6. Again, let us read the problem. Observe our netiquette. Just turn off your microphones when someone is discussing something. Okay. Then for number 6, let us proceed. Number 6. The problem is a certain coal has the following ultimate analysis. The analysis per mass, percentage by mass, the carbon is 70%, hydrogen is 3%, oxygen is 4%, nitrogen is 5%, sulfur is at 6%, the ash is at 5%, moisture is at 7%. Now we will determine the theoretical and actual air fuel ratio if excess air is a quarter of a total. So that is 25% of the total air fuel ratio. Okay. So in this problem, you are first asked to find the theoretical air fuel ratio. And this is coal. And remember, you may recall that we have to use what formula? Go back to your module. Okay, so let us go back with your module. The formula will be for air fuel ratio theoretical, that is equal to 11.5 C plus 34.5 multiplied by the multiplied with the difference between the hydrogen and the oxygen divided by 8 plus 4.3 of your sulfur. By that, you can get the theoretical air fuel ratio. So let us solve. So to solve, let me first okay. Okay, so let us solve now. For the air-fuel ratio, it is given by the formula 11.5C. Hello? 11.5C plus 34.5 34.5 H minus O divided by 8 plus 4.3 of your sulfur. Now, since we are given percentages of your mass in terms of the composition, chemical compositions, or the element, we will have them as decimal forms. So, 11.5, carbon is 70%, so we'll put that as 0.7 plus 34.5 H is H is 3%, so that is 0.03 minus the oxygen is 4%, 0.04 divided by 8 plus 4.3. S is S is 6%. Excuse me. 4.3 S is 6%. 0.606. Okay. So, that is for the theoretical. If you will get the value for your actual fuel ratio, you should multiply it with the 100% or the air fuel of the theoretical, air fuel ratio of the theoretical multiplied by 1 plus your excess air in percentage. This one. Let us fix that. Air fuel actual. Okay. So we will first solve for the air fuel ratio, theoretical air fuel ratio. So let's go with your calculator. All your calculators. Then assist me. Okay. So let us clear. Okay. Now, this is the way you will solve this. Okay. Now, you have to first 11.5, input that, and then alpha A. You don't have any value for A. Okay, Miss Kilasio de Vinagracia got the theoretical already. Let us proceed. Let us wait for those who haven't got the correct answer yet. 0.3 plus 0.04. No. The technique is like this one. So you can input different values if you want to. B minus C for oxygen. Divide by that by 8 plus 4.3 of your sulfur. We denote that as your D, alphabet D. And then you will press the function calculate. So A is 0.7 for 7%, 70%. Your B is 0.03 for 3%. And then for letter C, that is your oxygen, which is 4%, 0.04 in decimal. And then D, which is 6% for your sulfur, 0.06. So we'll arrive with 9.1705. So correct. Mr. Divin Nagracia again, and then Miss Kelasio. 9.1705. Kilogram air per kilogram fuel. So if you are given 25% excess air, all you have to do is multiply this with 1.25. So let us multiply with 1.25. 1.25. So 1 plus 25% excess air. So 11.4631. 11.4631 kilogram air per kilogram fuel. So now that is your actual and then theoretical air fuel ratio. Anyone who got the correct answer? Mr. Vinagracia again. Okay. Mr. Carlo Palad, thank you. So meron tayong natitirang 4 problems. We still have 4 problems. All you have to do is make that as your seat work so I can make that as a record in your finals. And then the final exam, I will release that on Friday morning. So can you do that on Friday morning or Friday evening?
Evening, sir. May class po kami ng
Sige, evening.
Sir,
Friday
may rep kami
morning.
nun, sir, eh.
IP. Okay, evening.
Pwede,
Exam week,
sir.
evening. Good for 3 hours.
Pwede, sir.
Good for 3 hours, 10 items. 5 items for cycles, 5 items for fuels and combustion. Katulad din ito. Ito lang yan. Solve for number 6. No. Solve for number 7 to 10.
7 to 10. Yes, sir. Thank you, sir.
7 to 10. Okay? You will pass that pag sinabi ko na lang sa Friday na lang. Okay?
Sir.
Oh,